NASA has recently uncovered some truly mysterious phenomena in the region surrounding Yellowstone National Park. These discoveries have ignited widespread speculation about the potential risks associated with the Yellowstone supervolcano, one of the largest and most dangerous volcanic systems on the planet. Though it may seem like a far-off worry to many, the findings have prompted experts to take a hard look at the current situation. The anomalous activity NASA has identified could indicate a shift in the geological dynamics of the area, and if history has taught us anything, such shifts could be ominous. To understand why this discovery is so significant, we need to start by revisiting Yellowstone's geological history and the science behind the monitoring efforts. Yellowstone sits atop a massive volcanic hotspot, where the Earth's crust is thin, allowing magma to rise closer to the surface. The result is a supervolcano that, though dormant for now, has the potential for catastrophic eruptions. The last major eruption occurred approximately 640,000 years ago, with smaller, non-eruptive geothermal events happening more frequently. For decades, Yellowstone has been under the watchful eyes of scientists, including those at NASA. Satellites and ground-based instruments monitor seismic activity, gas emissions, and the temperature changes within the park, especially in the areas that show geothermal activity, such as hot springs and geysers. Typically, this data has been relatively stable, with minor fluctuations in the geothermal fields being expected due to the ongoing volcanic processes beneath the surface. However, NASA's latest findings have shown some unusual patterns, such as unexplained bursts of heat and spikes in gas emissions, that do not align with the expected behavior of the supervolcano. NASA's Jet Propulsion Laboratory, JPL, has been instrumental in collecting data through various space-based technologies. Their Earth-observing satellites have been tracking changes in the region with remarkable accuracy. These satellites use infrared and thermal imaging to detect heat variations on the Earth's surface. Over the past few months, these instruments have picked up sudden increases in temperature in areas that are not typically hot spots. These temperature fluctuations are odd because they do not align with any of the usual geothermal patterns seen in Yellowstone. While it's not unusual for the volcano to release heat from deep within the Earth, the intensity of these bursts is raising alarm bells. The heat anomalies that have been detected are not just a minor irregularity. The intensity of the heat spike suggests that magma may be moving more than expected beneath the surface, possibly shifting or rising closer to the crust. This could be an indication of increased volcanic activity, though not necessarily a sign of an impending eruption. Magma movement is typically accompanied by heat and gas emissions, which in turn can change the way the land behaves. Alongside these heat anomalies, there have been significant increases in gas emissions, specifically carbon dioxide. Carbon dioxide is a natural byproduct of volcanic systems, and in areas like Yellowstone, it's commonly emitted through geysers and fumaroles. However, NASA's data shows an unusual surge in CO2 emissions, especially in areas far from the active geyser fields. Increased levels of carbon dioxide can be an early warning sign of magma pushing upwards. When magma rises towards the surface, it releases gases like carbon dioxide, sulfur, and water vapor, and this could suggest that the magma is in motion beneath Yellowstone. These changes in temperature and gas emissions are not in themselves proof of imminent volcanic eruption. However, they are important signs that the system underneath Yellowstone is becoming more dynamic. It's as if the supervolcano is shifting its gears beneath the surface. For scientists, the key question becomes, what exactly is causing these fluctuations, and could they lead to something more? For most of the past century, the supervolcano has been relatively stable, with only minor geothermal activity. But this new development could point to an underlying change. The heat spikes and gas emissions have raised questions about the stability of the magma chambers beneath the park. A typical volcanic system has a deep reservoir of molten rock, or magma, beneath the surface. This magma, when it rises toward the surface, can cause the ground to swell, heat up, and emit gases. At Yellowstone, the magma reservoir is not a simple, static pocket but a complex, interconnected system of chambers that can move and shift over time. In recent years, scientists have observed slight upticks in seismic activity, which might suggest that there is more pressure building in the system than previously realized. It's like the magma is being pushed around in ways that haven't been seen before, which is what's causing the unusual heat and gas readings. Seismic activity is another crucial element in understanding what's going on beneath Yellowstone. While the park is known for its relatively low levels of seismic events compared to other volcanic regions, small tremors are a regular occurrence. These tremors are typically attributed to the movement of magma or tectonic plates deep within the Earth. Recently, however, there has been a noticeable increase in the frequency of these seismic events. The tremors are not massive earthquakes, but they are more frequent and intense than what would be expected for a stable area like Yellowstone. These increased tremors could be a sign that pressure is building up beneath the surface, possibly in response to shifts in the magma reservoirs. It's important to remember that seismic activity and gas emissions alone do not necessarily indicate that Yellowstone is gearing up for an eruption. Volcanoes like Yellowstone are incredibly complex systems, and the changes observed could just be part of a normal cycle. Magma moves and shifts regularly within the Earth's crust, but it typically takes thousands of years for a significant eruption to occur. Still, when unusual patterns emerge, especially ones that haven't been seen before, it's worth investigating further. Despite the relatively low chances of an immediate eruption, the idea that something might be changing beneath Yellowstone is undeniably fascinating. History has shown us that volcanic systems can change their behavior unpredictably, even in regions that were once thought to be dormant. Consider the case of Mount St. Helens in Washington, which erupted with little warning in 1980. The eruption was preceded by several months of seismic activity and gas emissions, but the scale and intensity of the eruption shocked the world. Though Yellowstone's volcanic activity is very different, the Mount St. Helens eruption serves as a reminder of the potential for volcanic systems to surprise us, even when the data seems stable. Another example that illustrates the unpredictable nature of volcanic activity is the eruption of Iceland's Age of Geological volcano in 2010. For months, scientists had been monitoring increased seismic activity in the region, but no one expected the eruption to be as explosive as it was. The ash cloud that resulted disrupted air travel across Europe for weeks, highlighting how a seemingly small event in a monitored volcanic system can have far-reaching effects. Like Yellowstone, the Age of Geological volcano is part of a larger volcanic hotspot, and its behavior can be influenced by a range of factors, including shifts in tectonic plates and the movement of magma. These real-world examples serve as reminders of how volatile volcanic systems can be. Just because Yellowstone has been relatively stable doesn't mean it will remain so indefinitely. The recent findings from NASA are part of a much larger puzzle, one that involves understanding how volcanic systems behave over time and what causes them to become more active. As we continue to monitor these changes near Yellowstone, the world will be watching closely to see if this anomalous activity is just a temporary fluctuation or the first sign of a larger, more profound change in the supervolcano. As these intriguing patterns continue to unfold, the scientific community will undoubtedly be under increasing pressure to answer the big question: should we be worried? While there's no immediate cause for panic, the rise in temperature, gas emissions, and seismic activity warrants closer scrutiny. The idea of a supervolcano eruption might seem like something out of a disaster movie, but the reality is far more complicated. For now, scientists continue to study the data, striving to uncover the meaning behind these strange developments. As NASA continues to monitor the developments near Yellowstone, more questions are being raised about the broader implications of these findings. The data gathered so far suggests that the system beneath the park is experiencing shifts that are not entirely understood, and these shifts could have far-reaching consequences. One key aspect that experts are paying close attention to is how the movement of magma could affect the surrounding environment. While a full-blown eruption may be many years away, it is essential to understand the broader context of these changes in order to predict what might come next. To put this into perspective, consider the impact of previous volcanic eruptions on local ecosystems. Volcanic activity often results in the release of ash, gases, and particulate matter into the atmosphere, which can significantly alter the environment. A large eruption at Yellowstone could send ash clouds across much of North America, causing disruption to agriculture, transportation, and daily life. The potential impact on global weather patterns is another significant concern. In the past, volcanic eruptions have been linked to temporary cooling of the Earth's climate, a phenomenon known as volcanic winter. A major eruption at Yellowstone could trigger a shift in weather patterns worldwide, leading to cooler temperatures, changes in precipitation, and disruptions to ecosystems. Even smaller volcanic events, like the recent increase in heat and gas emissions, can have an immediate impact on the local environment. The surrounding area could experience increased geothermal activity, such as new geysers forming or changes in the behavior of existing hot springs. These changes could affect local wildlife and vegetation, as many species depend on the stable geothermal environment for survival. The park's unique ecosystem, including species like bison, elk, and bears, could face challenges as their habitat is altered by increased geothermal activity. One of the most striking aspects of the current situation is the rapid pace of change. Scientists have observed a sudden uptick in heat emissions and seismic activity, which suggests that whatever is happening beneath Yellowstone is occurring at an accelerated rate. This could indicate a shift in the dynamics of the magma system that could have profound implications. In previous years, scientists have noticed gradual, almost imperceptible changes in the behavior of the supervolcano, but nothing quite as dramatic as the current fluctuations. This has led some to wonder if the supervolcano is preparing for a larger, more noticeable eruption in the future, though there is still no clear evidence to support this theory. The key factor that has many experts on edge is the unpredictability of volcanic systems. While there are sophisticated tools and monitoring systems in place today, they cannot always predict how a volcano will behave. This uncertainty was demonstrated in the 2010 eruption of Iceland's Age of geological volcano, which took scientists by surprise despite months of seismic activity monitoring. The eruption not only disrupted air travel for weeks but also had long-term economic and environmental impacts. What made this event particularly startling was the way it unfolded. Despite the signs, the eruption was more intense than expected and created far-reaching consequences. At Yellowstone, we are seeing a similar unpredictability in the form of rising heat levels and gas emissions. While it's not yet clear what this will lead to, it is a reminder that even the best technology can only predict so much. The unpredictability of volcanic systems means that scientists must be cautious, always considering the possibility that small changes could lead to larger, more dramatic events. The current activity near Yellowstone is a reminder that the supervolcano, despite its apparent dormancy, remains an active and potentially dangerous system. As NASA continues to monitor the situation, there are ongoing discussions about what steps, if any, should be taken to prepare for potential risks. Should the surrounding population take any precautions, or is this just another series of natural fluctuations that will eventually subside? Experts remain divided on the issue, with some arguing that the current activity is no cause for concern, while others believe that we should be more vigilant. The complexity of volcanic systems makes it difficult to predict how they will behave in the coming months or years, but one thing is certain: the more we understand about these processes, the better equipped we will be to respond to any potential threats. In addition to monitoring the heat and gas emissions, there is also an increased focus on the seismic activity occurring around Yellowstone. The tremors that have been detected, while not large enough to cause immediate concern, are being closely watched. The frequency of these tremors has increased in recent months, and scientists are working to determine whether this could be a sign of shifting tectonic plates or increased magma movement. Seismic events often precede volcanic eruptions, but they can also be caused by other geological processes, making it difficult to determine the exact cause of the tremors. Interestingly, the recent surge in seismic activity has not been isolated to Yellowstone alone. Other parts of the western United States, including parts of Nevada and Idaho, have also seen an uptick in seismic events. Some geologists suggest that these tremors could be linked to larger tectonic processes occurring beneath the Earth's crust. However, the fact that these events are happening near Yellowstone has raised questions about whether they are related to the supervolcano itself. Despite the increase in seismic activity, scientists continue to reassure the public that the risk of a catastrophic eruption is still low. The likelihood of a major eruption at Yellowstone is exceedingly rare, with some estimates suggesting that the chances of such an event occurring in the next few thousand years are less than 1 in 10,000. Nonetheless, the current changes in the region warrant close monitoring, as even minor shifts in the system could have significant effects. As these anomalies continue to unfold, scientists are working around the clock to gather as much data as possible. By using a combination of ground-based instruments, satellite imagery, and seismic monitoring, they hope to gain a clearer picture of what is happening beneath the surface of Yellowstone. The data they gather will be crucial in helping to predict any future activity, whether that be a minor geothermal event or something more significant. In the meantime, residents and visitors near Yellowstone are being encouraged to stay informed about the latest developments. While there is no immediate danger, experts recommend keeping an eye on official updates and taking precautions as needed. Yellowstone remains a place of beauty and wonder, but it is also a volatile environment, and understanding the risks is an essential part of living in or visiting the area. As the data continues to flow in, scientists are exploring all possible avenues to understand the anomalous activity near Yellowstone. One of the key areas of focus is the rate at which magma is moving within the Earth's crust. While the supervolcano at Yellowstone is known for its immense size, the movements of magma within the system have been largely unpredictable. In the past, the magma chambers beneath the park have been relatively stable, but the recent shifts in heat and gas emissions could suggest that magma is becoming more dynamic than expected. What makes this situation even more intriguing is the way in which magma behaves beneath the Earth's surface. Magma isn't a stagnant force, it moves, shifts, and can even cause cracks in the surrounding rock. The recent bursts of heat detected by NASA's satellites could be the result of magma rising and moving through the Earth's crust at a faster rate than anticipated. As magma rises, it forces its way through smaller cracks in the Earth's crust, causing seismic tremors. This process, known as magma ascent, could explain some of the increased seismic activity observed near Yellowstone. While the tremors have been relatively minor, the increase in frequency suggests that something is shifting beneath the surface. Magma ascent has been linked to several volcanic events throughout history. A well-known example is the eruption of Mount Vesuvius in 79 AD, which decimated the Roman cities of Pompeii and Herculaneum. In the years leading up to the eruption, there was increased seismic activity in the region as magma began to rise toward the surface. The tremors were initially dismissed as minor, but they ultimately preceded one of the most catastrophic volcanic eruptions in history. While Yellowstone's situation is not nearly as dire, the parallels between these events are hard to ignore. The heightened seismic activity at Yellowstone could be a sign that magma is moving in ways that could result in more significant geological events in the future. NASA's involvement in monitoring Yellowstone's activity is part of a broader push to understand the planet's volcanoes. The agency's Earth-observing satellites are designed to detect subtle changes in the environment, including heat, gas emissions, and seismic activity. These tools are helping scientists track shifts in volcanic systems in real time, allowing them to stay ahead of potential dangers. The idea of using satellite technology to monitor volcanoes is not new. In fact, NASA has been using similar techniques to monitor volcanic eruptions in other parts of the world for years. One example is the 2018 eruption of the Kilauea volcano in Hawaii. Satellites were able to detect changes in temperature and gas emissions long before the eruption began, giving scientists valuable insight into the event's progression. NASA's satellite data, combined with ground-based observations, is helping experts paint a more complete picture of the situation at Yellowstone. In addition to tracking the heat and gas emissions, scientists are also examining the ground deformation around the park. Ground deformation occurs when the surface of the Earth shifts due to underlying geological processes. This can be caused by the rising of magma, the movement of tectonic plates, or the compression of rock layers. At Yellowstone, scientists have observed slight changes in the elevation of the land, which could be linked to the shifting of magma beneath the surface. These deformations may seem minor at first, but they are a vital indicator of how the volcanic system is evolving. Even small shifts in the ground could be a precursor to something more significant. While ground deformation is a common occurrence in volcanic regions, the current changes near Yellowstone are particularly intriguing. In some areas, the ground has been rising at an unusual rate, suggesting that magma may be slowly pushing its way upwards. This process could eventually lead to the formation of new geothermal features, such as geysers or hot springs, as magma interacts with water beneath the Earth's surface. If this process continues, it could result in dramatic changes to the landscape of Yellowstone, potentially creating new features or altering the behavior of existing ones. This possibility is not far-fetched. Over the past few decades, Yellowstone has seen the formation of new geothermal features, such as the Norris Geyser Basin, which has been particularly active. The creation of new geysers and hot springs is a direct result of geothermal energy moving through the Earth's crust. As the magma rises, it heats the surrounding water, creating the dramatic geysers that the park is famous for. These geothermal events are not necessarily dangerous, but they do illustrate the dynamic nature of Yellowstone's volcanic system. The possibility of new geothermal features forming in the wake of increased magma movement is a real consideration, and scientists are closely monitoring these changes. The growing body of evidence pointing to increased magma movement beneath Yellowstone has led to renewed discussions about the long-term risks of volcanic activity in the region. While the chance of a massive eruption remains low in the near future, the possibility of smaller-scale events, such as an increase in geothermal activity, remains high. The creation of new geothermal features, while fascinating, could have significant implications for the local environment. If the rising magma continues to push upward, it could lead to the formation of new geysers, hot springs, and fumaroles. While these phenomena would likely attract tourists, they could also change the way the park operates and affect the habitats of local wildlife. For example, certain species of plants and animals may rely on stable geothermal environments for survival, and any changes to these systems could disrupt their habitats. The impact of these changes is not limited to the local ecosystem. As seen in other volcanic regions, significant changes in geothermal activity can have economic consequences as well. The Yellowstone National Park is one of the most visited national parks in the United States, drawing millions of tourists each year. The attraction of the park's geothermal features is a major driver of the local economy, and any disruption to these features could impact tourism. Additionally, changes in the park's landscape could affect the infrastructure needed to accommodate visitors, from hiking trails to hotel accommodations. While the focus has been on the potential geological risks, the broader consequences of these changes cannot be ignored. Increased geothermal activity, changes in the landscape, and the creation of new features could alter the very nature of the park itself. In the future, Yellowstone could become a more dynamic and unpredictable environment, with new geothermal events occurring at regular intervals. These changes could make the park even more intriguing to scientists, but they could also create challenges for park management and local communities. As the situation at Yellowstone continues to evolve, there is growing concern about the possible social and economic ramifications. The park itself is not just a geological wonder but also a significant part of the economy for nearby towns. For decades, Yellowstone has been a major source of joy and confidence, with millions of people visiting each year to witness its geothermal wonders, provide diverse wildlife, and stunning landscapes. However, if the current anomalous activity continues, it could reshape the tourism landscape. One of the biggest concerns is the potential for increased unpredictability in the region. Tourists flock to Yellowstone with the expectation of experiencing the park's natural beauty in a relatively safe environment. However, if new geothermal events begin to take place more frequently or existing features behave unpredictably, it could deter visitors. For instance, sudden surges in hot spring activity, unexpected eruptions from geysers, or even the emergence of new fumaroles could present safety risks. While many of these geothermal events are harmless in isolation, their unexpected occurrence could create chaos in an area that is not designed to handle the swift changes of a more volatile landscape. The logistical challenges of managing a park with rapidly changing geothermal features are immense. The park's infrastructure, which includes trails, roads, and visitor centers, could be put at risk if seismic activity causes shifts in the land. One real-world example of the difficulties associated with managing a volcanic area occurred in 2014, when a series of small eruptions at Mount Antake in Japan led to the tragic deaths of hikers. The eruption was unanticipated, and the area was not closed off in time to protect visitors. Yellowstone's sheer size and the unpredictable nature of volcanic systems make it a particularly challenging environment to manage. If magma movements continue to cause ground deformation, local authorities may need to alter the park's layout, close off certain areas, and possibly relocate some attractions or visitor services to ensure public safety. The potential for these changes to disrupt not just the park itself, but the surrounding communities, is another point of concern. For example, towns like West Yellowstone, Gardiner, and Cody are heavily dependent on tourists who visit the park. A shift in visitor patterns, whether due to safety concerns or changes in the park's geothermal features, could significantly impact these towns' economies. The service industries that rely on tourism, hotels, restaurants, and tour operators, could face economic downturns if fewer people come to the area. Conversely, the increased monitoring and potential evacuation procedures could create new costs for local governments and emergency services. While the immediate risk of a catastrophic eruption remains low, the changes happening at Yellowstone have caught the attention of scientists, government officials, and local communities. The broader concern is how to prepare for any future volcanic event, even if it is not as extreme as what some fear. Early warning systems, which track seismic activity, heat levels, and gas emissions, are being put to the test. For instance, Yellowstone already has a sophisticated monitoring system that includes seismic sensors, GPS instruments, and satellite technology. These have a long-standing history of monitoring volcanoes, including their eruptions and post-eruption landscapes, using advanced imaging tools. By applying this technology to Yellowstone, scientists can potentially detect early signs of volcanic activity. If new eruptions or shifts in the geothermal landscape are imminent, early detection could give nearby communities time to evacuate and prepare for the event. A notable example of how early detection has proven vital in the past is the 2009 eruption of Mount Redoubt in Alaska. NASA's satellites detected heat signatures in the volcano before it erupted, which provided critical lead time for officials to issue warnings. This was especially important because Redoubt is located in a region with dense air traffic, and the eruption sent ash clouds high into the atmosphere, threatening planes flying overhead. The timely detection of the volcanic activity allowed for precautions to be taken, reducing potential damage to property and infrastructure. The ability to detect changes beneath Yellowstone before they become hazardous is a major priority for scientists, but there are limitations to what current technology can achieve. While the tools used by NASA and other agencies are incredibly advanced, predicting the precise timing, location, and intensity of volcanic events remains a difficult challenge. The recent anomalies observed near Yellowstone, while concerning, have not yet shown clear signs of leading to an imminent eruption. It's possible that these changes are part of the natural cycle of geothermal activity, which has fluctuated over millions of years. However, because the consequences of an eruption at Yellowstone would be catastrophic, scientists are being cautious in their assessments. One example that underscores the complexity of volcanic prediction occurred with the 1980s. Even with modern technology, it's crucial to remember that no system can guarantee 100% certainty. While early detection tools are vital, they are not foolproof. Therefore, it's important to continue research and monitoring efforts around Yellowstone to stay ahead of potential risks. As NASA and other agencies continue to study the park's seismic activity, heat signatures, and gas emissions, it's likely that new data will shed more light on the current situation. Whether this activity represents the early stages of something much larger or is just part of a natural cycle remains to be seen. In either case, the situation demands attention, and the potential for future volcanic events, no matter how small, must be taken seriously. As the monitoring of Yellowstone intensifies, the data collected is revealing some unexpected patterns that have further piqued the interest of scientists and experts. In particular, The way the park's geothermal systems are reacting to the increased seismic activity is unlike anything seen in the past. This presents a deeper question: is the anomaly an isolated event, or is it part of a larger, more significant pattern of geologic change? Scientists are examining every possible explanation, with some even considering the possibility of a more widespread shift in Earth's geologic activity, which could have ripple effects far beyond Yellowstone. One significant aspect of this phenomenon is the concentration of heat beneath the park. Recent data shows that certain geothermal areas, particularly around the Norris Geyser Basin, have been registering higher than normal temperatures. These increases are not only limited to the geysers and hot springs but extend beneath the surface as well. This could suggest that there is a gradual accumulation of heat, possibly due to magma rising from deeper layers within the Earth's crust. Geothermal energy, which powers the geysers and hot springs, is a direct result of the heat from magma chambers beneath the Earth's surface. When magma moves or shifts in a way that is not typical, it could lead to a dramatic increase in the geothermal activity at Yellowstone, potentially creating new geysers, hot springs, or even fumaroles that were previously non-existent. What is concerning to many scientists is the rate at which the temperature is rising. As any geothermal expert would tell you, heat buildup is a normal part of the volcanic process. However, when the rate of increase exceeds the usual patterns, it begins to raise questions. For example, in 2004, there was a noticeable increase in the temperature around the Yellowstone caldera. This change sparked a brief period of heightened concern, but the activity eventually stabilized. In this current situation, however, the heat spikes seem to be happening at a faster pace, suggesting a more immediate, perhaps more dangerous, trend. This rapid increase in temperature could also be indicative of something else: pressure building within the Earth's crust. As magma rises, it can cause a buildup of pressure in the surrounding rocks. This pressure can lead to the fracturing of rock layers, creating cracks and fissures through which gas and steam can escape. In Yellowstone, scientists have recorded higher concentrations of sulfur and other gases being released into the atmosphere. This type of gas release is typical of a volcano in a period of heightened activity. The combination of increasing temperatures, rising gas emissions, and increased seismic tremors paints a picture of a system under stress. The release of gases from Yellowstone is significant not just for its potential to affect the environment, but also for the implications it may have for understanding the park's volcanic behavior. Gases like sulfur dioxide, carbon dioxide, and hydrogen sulfide can be indicators of magma rising through the crust. When magma moves toward the surface, it releases these gases, which can often be detected by satellites or ground-based sensors. These gases are typically emitted through volcanic vents, fumaroles, or geysers, and their presence in increasing concentrations can be a sign that the volcanic system is becoming more active. It's important to note that while gas emissions are common in volcanic regions, the amount of gas released from Yellowstone in recent months has been notably higher than in the past. In 1980, when Mount St. Helens erupted, researchers noted an increase in gas emissions as magma began to rise toward the surface. In the years leading up to that eruption, the volcano emitted higher than usual levels of sulfur dioxide, which was one of the key indicators that the volcano was becoming more active. The similarity in patterns between Yellowstone and Mount St. Helens, although speculative, cannot be ignored. As the gas levels rise in Yellowstone, another significant factor comes into play: the interaction between these gases and the surrounding environment. The release of sulfur and other compounds into the atmosphere could have an effect on local air quality. Increased gas emissions can lead to the formation of acid rain, which can be harmful to both the environment and human health. While Yellowstone is not an urban center, the region's proximity to local communities could make air quality a concern if gas emissions continue to rise. Additionally, increased acidity in local water sources could pose a threat to wildlife, particularly species that rely on the park's rivers and lakes. Beyond the environmental impact, the increased gas emissions could also indicate that the Yellowstone supervolcano is experiencing significant internal changes. As magma rises, it pushes against the surrounding rocks, which can cause the release of gases from within the Earth. These gases act as a pressure valve, allowing the system to release the built-up tension. However, if the gas emissions continue to increase, it could suggest that the magma is reaching a point where it will no longer be able to release pressure in such a controlled manner. In other words, if the gas levels continue to rise unchecked, there could be a risk of more violent eruptions, with ash clouds and pyroclastic flows. However, experts caution that while these signs may appear alarming, they do not necessarily mean that a catastrophic eruption is imminent. It's important to remember that Yellowstone is a dynamic and active volcanic system, and its geothermal activity is highly variable. The fact that we are observing these changes does not automatically mean that an eruption is about to occur. Volcanoes can remain active for thousands of years without erupting, and many of the changes observed at Yellowstone may be part of a long-term, natural cycle. The key is to monitor the activity closely and assess whether the trend continues or if it stabilizes. In the past, scientists have been able to predict volcanic eruptions based on changes in gas emissions, seismic activity, and ground deformation. While predictions are never 100% accurate, they have proven to be effective in some cases. For instance, in 2000, scientists at Yellowstone detected an increase in seismic activity and gas emissions. At the time, it was suspected that the park might experience an eruption. However, after several months of monitoring, the activity began to subside, and no eruption occurred. This example serves as a reminder that while volcanic systems are unpredictable, monitoring tools are getting better at giving early warnings. In the case of Yellowstone, scientists are closely watching the park's gas emissions, seismic activity, and ground deformation patterns. If these signs continue to escalate, they may issue warnings to the public, providing both residents and tourists with adequate time to prepare. The challenge, however, lies in the unpredictable nature of volcanic systems. Even with the best monitoring systems, predicting exactly when and where an eruption might occur is still a difficult task. For now, the situation remains under close watch, with researchers and authorities on high alert for any further developments. As the monitoring of Yellowstone progresses, new data and observations are continuing to shape the way experts approach the current anomalous activity. The primary concern for many scientists is the long-term stability of the park's geothermal systems. With the increasing seismic activity and the shifts in heat patterns, the question arises: how much can Yellowstone continue to experience these changes before something major occurs? The natural world is filled with cycles, some slow and imperceptible, others rapid and devastating. When it comes to Yellowstone, the idea that we are witnessing an anomaly in a centuries-old cycle is one of the more unsettling possibilities. One of the more intriguing aspects of this situation is the geological history of Yellowstone itself. Over the course of millions of years, the park has experienced several episodes of intense volcanic activity. These eruptions, while not common, have had lasting impacts not only on the landscape but on the global environment. The eruption that occurred approximately 640,000 years ago was so large that it left behind the vast caldera that we see today. That eruption was one of the largest known eruptions in Earth's history. The current anomalous activity, when viewed through the lens of geological history, might be a sign that Yellowstone is approaching a critical point in its cycle. The challenge lies in determining if these changes are simply part of the natural cycle, or if they indicate something much more dangerous on the horizon. Interestingly, studies of other supervolcanoes around the world have revealed similar patterns in geothermal and seismic activity before major eruptions. For instance, scientists monitoring the Campi Flegrei caldera in Italy have noticed an increase in seismic activity and ground deformation in recent years. This caldera, much like Yellowstone, has the potential to produce catastrophic eruptions. However, it is also important to note that not every volcanic system follows the same pattern. Some supervolcanoes exhibit significant changes in their geothermal activity without ever erupting. In the case of Yellowstone, we are dealing with an extraordinarily complex system that is still not fully understood. While it's tempting to draw comparisons with other calderas, each system has its own quirks and peculiarities, making predictions all the more difficult. Another key factor in understanding the current situation is the role of water in Yellowstone's geothermal activity. The park is home to a complex network of hot springs, geysers, and fumaroles, all of which are fueled by the interaction between water and the geothermal heat below. In recent months, there have been reports of changes in the temperature and water levels in some of the park's famous geothermal features. While hot springs may naturally fluctuate in temperature, the degree to which they are changing could provide valuable clues about the state of the underlying magma chamber. A slight increase in the temperature of hot springs may suggest that more heat is being released from below, indicating a potential shift in the geothermal system. The heat beneath Yellowstone is not only responsible for its geysers and hot springs but also for the unique ecosystems that thrive in the park's geothermal areas. These areas host specialized microbes that are capable of surviving in extreme conditions. As the heat intensifies, it could potentially disrupt these ecosystems, leading to cascading effects on the local wildlife. For instance, if the temperature of a hot spring increases beyond a certain threshold, the delicate balance of microorganisms could be upset, causing ecological disruptions. Furthermore, the higher concentrations of gases like sulfur and carbon dioxide in the air could affect the plants and animals in the area. While Yellowstone's ecosystems are incredibly resilient, any significant shift in geothermal activity could have long-lasting impacts on the park's biodiversity. Given the widespread concerns about the impact of these changes, it's essential to consider how Yellowstone's anomalous activity could affect not only the environment but the global climate as well. As mentioned earlier, large volcanic eruptions have the potential to disrupt global weather patterns. The 1815 eruption of Mount Tamborai in Indonesia, for example, led to what became known as the year without a summer, where global temperatures plummeted, causing crop failures and food shortages. A major eruption at Yellowstone, while not guaranteed, could potentially have similar effects on global temperatures. The ash clouds released during such an event could block sunlight, leading to a dramatic cooling of the Earth's surface for years to come. This phenomenon, known as volcanic winter, could disrupt agriculture, cause food shortages, and create widespread social unrest. The impact of such an event on human societies would be profound, with the potential for political instability and economic disruption. While these worst-case scenarios are speculative at best, they serve to underscore the global significance of Yellowstone's volcanic system. Even without an eruption, the effects of increased geothermal activity and gas emissions could be felt far beyond the park's boundaries. For example, the sulfur dioxide released from Yellowstone's geothermal features could contribute to the formation of acid rain, which can have detrimental effects on crops, forests, and bodies of water. In addition, the release of carbon dioxide from the park's fumaroles could have an impact on air quality, particularly in nearby areas. The presence of increased amounts of greenhouse gases in the atmosphere could also contribute to climate change over the long term, although the contribution of Yellowstone to global warming would likely be minimal compared to human activities. It is important to recognize, however, that these are all scenarios based on hypothetical outcomes. Currently, the anomalous activity observed at Yellowstone has not been linked to any immediate eruption. While it is crucial to continue monitoring the park's geothermal systems and seismic activity, there is no definitive evidence to suggest that an eruption is imminent. The current changes may simply represent part of Yellowstone's natural fluctuations. Nonetheless, given the scale of the potential consequences, the situation remains one that warrants close attention and continued research. As scientists continue to study the park's geothermal features, the focus is not just on predicting an eruption, but on understanding the underlying processes that drive the park's geothermal activity. By examining the relationship between seismic activity, gas emissions, and ground deformation, researchers hope to gain a clearer picture of the forces at play beneath Yellowstone. The goal is to identify patterns that may signal a shift toward more dangerous activity, giving local communities and governments the time needed to prepare for any potential threat. In addition to the scientific community, the general public also has a role to play in staying informed about the situation. Public awareness campaigns, led by scientists and government agencies, can help ensure that the people who live near Yellowstone and those who visit the park are aware of the risks and understand how to stay safe. Should the situation at Yellowstone continue to evolve, it will be critical for local authorities to have contingency plans in place to manage both the immediate and long-term impacts of any potential volcanic event. As the situation at Yellowstone continues to develop, it's becoming increasingly clear that the potential risks associated with the park's geothermal and volcanic systems cannot be underestimated. However, while some fear the worst, others argue that we are simply witnessing natural fluctuations within a long-term geological cycle. The reality is, the Earth's volcanic systems, including Yellowstone, are inherently unpredictable. The combination of increasing seismic activity, rising temperatures, and altered gas emissions does create a sense of urgency, but it is essential to maintain a balanced perspective. While scientists have made significant strides in understanding these systems, there is still much to be discovered about the complex interactions taking place beneath Yellowstone's surface. One of the most pressing concerns, and the subject of much debate among experts, is the potential for ground deformation. Over the past few months, there have been significant shifts in the land surrounding the Yellowstone caldera, as detected by ground-based radar systems and satellite imagery. These changes, known as subsidence or uplift, are often indicative of shifting magma beneath the surface. In particular, the western portion of the park has shown signs of slight upward movement, suggesting that magma might be rising toward the surface. These deformations can occur when magma accumulates in a chamber below the Earth's crust, pushing against the surrounding rock layers and causing them to bulge. Although such deformations are not always indicative of imminent eruptions, they can serve as early warning signs. In the case of Yellowstone, the amount of ground uplift detected is relatively minor, but it is still a noteworthy development. The problem lies in the fact that even minor changes in the land's surface can sometimes be precursors to larger, more destructive shifts in the volcanic system. For example, the eruption of Mount St. Helens in 1980 was preceded by noticeable swelling in the mountain's flank, which was caused by the accumulation of magma beneath the surface. This swelling was one of the key indicators that scientists used to predict the eruption, although they were unable to predict the exact timing of the event. The situation at Yellowstone, while different in many ways, raises similar concerns about the possibility of unexpected volcanic activity. As the ground continues to shift and the heat beneath the park increases, scientists are focusing on gathering as much data as possible. They are deploying a range of monitoring tools, including seismic sensors, thermal cameras, and gas detectors, in an attempt to create a clearer picture of what's happening beneath Yellowstone's surface. These monitoring systems are designed to pick up on subtle changes in the park's geothermal features, providing valuable insights into the potential behavior of the volcanic system. For example, the addition of ground-based sensors that can measure minute changes in ground deformation has helped experts track the movement of magma more precisely, allowing them to spot warning signs long before they become obvious to the naked eye. Another crucial area of research is the ongoing monitoring of Yellowstone's gas emissions. While the park has always been a source of geothermal gases, recent increases in sulfur dioxide, carbon dioxide, and hydrogen sulfide emissions have caught the attention of researchers. These gases are typically released as magma rises toward the surface and can provide important clues about the state of the underground volcanic system. As the gases escape through the park's fumaroles and geysers, they carry with them valuable data that scientists can analyze. By studying the composition and concentration of these gases, researchers hope to gain a better understanding of the mechanisms that drive Yellowstone's geothermal activity. Interestingly, scientists are also looking at the relationship between the changes in Yellowstone and other volcanic systems around the world. As noted earlier, there are certain similarities between the current situation at Yellowstone and the conditions leading up to previous volcanic eruptions. However, there are also important differences that must be considered. Each volcanic system operates under unique conditions, influenced by factors such as the composition of the magma, the amount of pressure within the Earth's crust, and the overall geological structure of the region. For example, the volcanic system at Yellowstone is different from that of the nearby Cascadia subduction zone, where major earthquakes and volcanic eruptions are triggered by the subduction of tectonic plates. While the tectonic setting in Yellowstone is not as straightforward, the region's volcanic history still provides valuable context for understanding the current situation. Despite the heightened concerns, it is essential to understand that volcanoes, especially supervolcanoes like Yellowstone, can behave in highly unpredictable ways. While some volcanic systems have eruptions that follow clear patterns, others remain dormant for millennia before suddenly becoming active again. The eruption of Mount Vesuvius in AD 79, for example, was unexpected and caught the ancient Roman world by surprise. Similarly, the eruption of Krakatoa in 1883 was preceded by several years of volcanic activity, but the scale of the eruption still took scientists and residents by surprise. These historical examples highlight the challenges faced by modern scientists when it comes to predicting volcanic eruptions. Even with advanced technology, the unpredictable nature of volcanic systems remains a significant hurdle in understanding their behavior. It's also important to consider that the risk of a catastrophic eruption at Yellowstone, while real, is still very low. The park has not experienced an eruption for over 640,000 years, and while this does not mean it is overdue, it does suggest that the caldera operates on a much longer cycle compared to other volcanic systems. Many scientists believe that the current activity is simply part of the natural fluctuation of the park's geothermal features. In fact, there is a strong possibility that the current seismic events and temperature changes are part of a slow and steady release of pressure, which might ultimately prevent a larger, more destructive eruption. This gradual release of energy, although concerning, may actually reduce the likelihood of a major event in the near future. Even with these reassurances, the global implications of a potential eruption at Yellowstone cannot be ignored. The sheer size of the supervolcano means that any eruption, even one of a smaller scale, could have catastrophic consequences not only for the local area but for the entire world. The amount of ash and gases released could disrupt air travel, cause crop failures, and alter weather patterns for years to come. While experts stress that the chances of such an eruption occurring in the immediate future are minimal, it is essential to keep monitoring the activity closely to ensure that any signs of danger are detected as early as possible. Given the potential global ramifications of a Yellowstone eruption, scientists and governments are working together to prepare for worst-case scenarios. They are developing contingency plans to protect residents and visitors to the park, as well as strategies to mitigate the effects of any volcanic activity on the broader environment. The goal is not to cause panic, but to ensure that we are as prepared as possible should the situation at Yellowstone take a dangerous turn. By monitoring the park's geothermal activity, seismic shifts, and gas emissions, scientists hope to provide early warning systems that can help prevent catastrophic outcomes. As the situation unfolds at Yellowstone, it's important to take a closer look at the broader implications for the scientific community and the general public. Scientists are often faced with the challenge of striking a balance between the urgency of their findings and the need to avoid causing unnecessary alarm. With Yellowstone, the unpredictability of volcanic systems means that, while monitoring efforts are critical, scientists must walk a fine line between encouraging awareness and managing fear. The park's geological systems are far more complex than we can fully comprehend at this moment, and every new bit of data gathered offers both potential answers and more questions. One of the ongoing challenges is determining the rate of magma movement beneath the surface. Even with cutting-edge seismic technology, it's difficult to pinpoint exactly where magma is within the Earth's crust at any given time. In recent months, new data from ground-based and satellite monitoring systems have shown unusual patterns of magma intrusion. These small pockets of magma are slowly working their way through cracks in the Earth's crust, sometimes creating areas of localized pressure that can be felt in the form of small tremors. As magma shifts and moves, it can create a sort of ticking clock effect, where the buildup of pressure causes more frequent, albeit minor, earthquakes in the region. These quakes are often not large enough to be immediately alarming, but their frequency and distribution gives scientists a unique glimpse into the behavior of the underlying magma chamber. Interestingly, some researchers have begun exploring how the interactions between magma and groundwater might play a significant role in the observed changes. Yellowstone's vast geothermal systems are fueled by a complex interaction between water, heat, and rock. As magma rises beneath the park, it encounters underground water reservoirs, which in turn cause localized boiling and geothermal eruptions. The heat transferred into the groundwater system can lead to shifts in pressure, creating what are known as hydrothermal events. These events can, in turn, increase the frequency and intensity of geysers and hot springs, which may not directly signal a volcanic eruption but could indicate subtle changes in the thermal energy being released by the system. Understanding these interactions between water and magma is crucial for predicting how the system might evolve over the coming years. Beyond the geothermal activity itself, Yellowstone's wildlife is being affected by the ongoing changes in the landscape. While many species within the park are well adapted to its volcanic environment, even minor shifts in the ecosystem can have cascading effects. One example of this is the behavior of animals near geothermal features. The bison, elk, and other animals that roam the park rely on a delicate balance of temperatures in certain areas to thrive. Changes in the geothermal landscape could cause shifts in the availability of these habitats, potentially driving wildlife away from areas where they have historically flourished. This shift could lead to disruption in the food chain, as smaller species and plant life could also be impacted by changes in temperature and water availability. In addition to the environmental concerns, the local human populations surrounding Yellowstone are facing their own set of challenges. While the park itself is located in a relatively remote area, the towns and communities that surround it, such as Jackson Hole and West Yellowstone, are heavily reliant on tourism. Millions of visitors flock to the area each year, drawn by the beauty of the geothermal features, the diverse wildlife, and the sheer awe of standing atop a supervolcano. Any change in the park's status could have significant economic repercussions for these regions. A sudden rise in seismic activity, ground deformation, or even an increased risk of a major eruption could lead to a decline in tourism, causing businesses that rely on visitors to suffer. Even the threat of an eruption, while not immediate, could scare off travelers, reducing the economic stability of these surrounding areas. On a larger scale, the heightened awareness of Yellowstone's potential risks could spark debates on the global response to supervolcanoes. In the past, volcanic eruptions, while disruptive, have been relatively localized. However, in the case of Yellowstone, the sheer size of the potential eruption means that the consequences would not be limited to nearby areas. If Yellowstone were to erupt on a large scale, it could alter the global climate for years, leading to disruptions in agriculture, global food supplies, and even altering weather patterns. The possibility of such an event raises serious questions about how prepared the world is for a volcanic disaster of this magnitude. Governments and organizations around the world would need to come together to coordinate a global response, from ensuring the safety of those in immediate danger to addressing the broader impacts on the global economy. As of now, the scientific community remains cautiously optimistic that the increased activity at Yellowstone does not signal an imminent eruption. Most experts agree that while the current changes are worth noting, they do not present an immediate threat. However, as with all natural disasters, it's the unpredictability of these systems that makes them so difficult to manage. Scientists continue to gather data, refining their models and predictions, but the truth is, we will not know for certain what lies ahead until more time passes. For now, the focus remains on monitoring the park's geothermal activity and preparing for potential developments, no matter how improbable they may seem. As we move forward, it's crucial that we continue to invest in research, technology, and preparedness. Advances in seismic monitoring, satellite imagery, and geothermal analysis are making it easier than ever for scientists to keep a close watch on Yellowstone. However, these advancements are only helpful if we take the necessary steps to act on the information they provide. Preparation, both on a local and global scale, will be key to minimizing the damage caused by any potential volcanic event. It's not a matter of if something will happen, but when and how. With that knowledge, the best we can do is ensure that we are ready for any possibility. Moreover, the experience at Yellowstone has already served as a wake-up call for many in the scientific community. In recent years, attention has turned to other dormant supervolcanoes around the world, many of which have remained inactive for centuries or even millennia. Monitoring efforts are being ramped up at locations such as the Toba caldera in Indonesia, the Lake Taupo supervolcano in New Zealand, and the Campi Flegrei in Italy, all of which share similar risks to Yellowstone. The interconnectedness of these global volcanic systems reminds us that we live on a dynamic, ever-changing planet. Our understanding of these systems is continually evolving, but what remains clear is that the need for monitoring, awareness, and preparedness has never been more urgent. As the Yellowstone situation continues to unfold, it's becoming increasingly clear that the scale of potential consequences, should anything catastrophic occur, would extend far beyond the borders of the park itself. While scientists continue to focus on monitoring the park's activity, the broader implications for public safety, global climate, and even the stability of various ecosystems are being considered. The fact that Yellowstone is considered a supervolcano, one of the few of its kind on Earth, adds a layer of complexity to this issue. Unlike smaller volcanoes, supervolcanoes have the capacity to dramatically alter the landscape, climate, and even the course of history. One of the more fascinating aspects of supervolcanoes like Yellowstone is their long-term impact on the global environment. A significant eruption could potentially send millions of tons of ash and sulfur dioxide into the atmosphere, which would have far-reaching effects on global temperatures. A large enough eruption could create a volcanic winter, a period of drastic global cooling caused by the sunlight-blocking effects of volcanic ash and aerosols in the atmosphere. This has happened in Earth's history before, most notably with the eruption of Mount Tambora in 1815, which triggered the year without a summer. In 1816, the effects of Tambora were so severe that crop failures led to widespread food shortages, famine, and social unrest. Imagine a similar event occurring at Yellowstone, but on a much larger scale. The potential for widespread global cooling and disruptions to the climate is something that scientists are beginning to study in more detail. Research into how the Earth's climate reacts to volcanic activity is critical for understanding just how much of an effect Yellowstone could have on global temperatures, weather patterns, and agricultural productivity. The potential for famine, mass migration, and geopolitical instability in the wake of such an event cannot be ignored. The global food supply could be severely impacted, leading to food shortages in regions that are dependent on agricultural systems affected by the volcanic fallout. This scenario, while still hypothetical, reminds us of how interconnected our world is, and how an event on one side of the globe can ripple across continents. In addition to climate concerns, the prospect of widespread ash fall from Yellowstone could have immediate and severe local impacts. The thick ash clouds produced by a massive eruption would bury nearby communities, potentially causing extensive damage to infrastructure, homes, and public services. In areas downwind from the eruption, transportation networks, such as airports, highways, and railways, could be shut down for extended periods. This would disrupt the movement of goods and people, affecting everything from emergency response teams to the availability of food and water in affected regions. The ash could also contaminate water supplies, further exacerbating the situation. Even beyond the direct effects of volcanic activity, scientists are concerned about the longer-term environmental consequences that could follow such an eruption. The combination of ash, toxic gases, and changes in atmospheric pressure could potentially damage delicate ecosystems around the world. Plants that rely on specific climate conditions might fail to adapt quickly enough, leading to long-term disruptions in food webs. Species of wildlife, already stressed by human-driven environmental changes, could face even greater challenges in the wake of a global climate shift. Certain species could be pushed to the brink of extinction, while others may thrive in the altered conditions, further disrupting the delicate balance of ecosystems. These disruptions could extend far beyond the park's borders, affecting biodiversity on a scale not seen in modern times. While these are the worst-case scenarios, the fact remains that Yellowstone's activity has captured the attention of the scientific community, policymakers, and the general public alike. The question is not whether we should prepare for the worst but how best to respond to the ongoing developments at the park. Scientists continue to refine their monitoring techniques, developing new tools to predict volcanic behavior with greater accuracy. However, Even with cutting-edge technology, it's impossible to predict with certainty when or how an eruption will occur. The very nature of supervolcanoes means they are difficult to study, as they tend to erupt on timescales that span thousands, or even millions of years. What may seem like a quiet period could suddenly shift, leaving little time for the world to prepare. One of the most crucial aspects of managing potential volcanic activity is early warning systems. In order to minimize loss of life and mitigate the effects of any eruption, experts are focused on enhancing our ability to detect early signs of an impending eruption. Ground deformation, rising gas emissions, and increasing seismic activity are all key indicators that could provide valuable information about the state of the Yellowstone caldera. However, even with all of these data points, predicting the exact timing of a volcanic eruption remains an elusive task. This is why ongoing research, including the development of new monitoring systems, is essential for staying ahead of any potential disaster. In parallel with the scientific community's efforts, governments around the world are beginning to take note of the potential implications of Yellowstone's activity. Agencies responsible for disaster management and preparedness are working to develop response plans that can be adapted to a variety of scenarios. These plans might include evacuation routes for residents living near the park, as well as strategies to distribute food, water, and other essential supplies in the event of a major eruption. International cooperation will also be crucial in preparing for the aftermath of such an event, especially if the effects are felt on a global scale. Another critical area of focus is the importance of public education and communication. In many cases, people living in close proximity to volcanic activity may not fully understand the risks involved, or they may be ill-prepared for what could happen. Increasing awareness about the signs of volcanic activity, as well as emergency preparedness plans, can help reduce the number of casualties in the event of an eruption. Communities near Yellowstone, and those in other regions with active volcanoes, need to be educated about the risks, as well as the practical steps they can take to ensure their safety. Even something as simple as developing an emergency kit and a family evacuation plan can make a significant difference when disaster strikes. What's also crucial in the context of Yellowstone is the increasing collaboration between scientists, governments, and the private sector. The park is not just a symbol of nature's raw power but also a hub of ongoing research. Universities, private research institutions, and tech companies are all coming together to pool their resources and expertise. By working collaboratively, these groups are making strides in developing new ways to detect seismic activity, track gas emissions, and analyze ground deformation in real time. This type of cooperation could be pivotal in developing a robust, global monitoring system capable of detecting volcanic changes and helping prevent large-scale disasters. At the same time, there is a growing need for long-term solutions to mitigate the effects of any potential eruption. While there is no clear answer to how to prevent or stop an eruption of this magnitude, scientists are looking into a range of ideas, including geoengineering projects designed to protect the planet's atmosphere from the devastating effects of volcanic ash. These efforts remain in their infancy, but they highlight the growing understanding of the potentially catastrophic impact supervolcanoes could have on the Earth's climate and ecosystems. Some have even proposed projects aimed at redirecting magma beneath the Earth's surface or injecting materials into volcanic chambers to control pressure. While these ideas remain speculative, they underscore the importance of continued research into innovative solutions for managing the long-term risks posed by supervolcanoes like Yellowstone. As we continue to examine the complexities surrounding Yellowstone, it's crucial to delve into the potential global consequences of an eruption. While much of the focus remains on the immediate risks to surrounding communities and ecosystems, the far-reaching implications for the planet as a whole are just as concerning. A supervolcano eruption, especially one as significant as Yellowstone, could cause widespread disruptions that transcend borders and affect millions, if not billions, of lives. These effects could manifest in numerous ways, from agricultural failures and economic downturns to societal instability and global migration patterns. One of the most alarming consequences of a major eruption would be the disruption of the global food supply. The combination of ash clouds, cooling temperatures, and shifting weather patterns could wreak havoc on agricultural systems around the world. Volcanic ash is highly toxic to plants, smothering crops and making it difficult for them to photosynthesize. The resulting crop failures could lead to massive shortages in staple foods like wheat, corn, and rice, which are essential to feeding the global population. In the worst-case scenario, this could trigger a global food crisis, with prices soaring as supply chains are disrupted, leading to widespread hunger and famine. The volcanic winter caused by the eruption of Yellowstone could dramatically alter the Earth's climate, with temperatures plummeting by several degrees across the globe. This shift in temperature would severely impact agricultural regions, especially those that rely on consistent growing seasons. In the United States, the Midwest, often referred to as the breadbasket of the world, could see its crops wiped out by the colder temperatures and ash fall. Countries around the world would also face similar challenges, particularly those in the southern hemisphere, which might experience more severe cooling due to shifts in atmospheric circulation patterns. The global agricultural market would likely collapse under the strain of diminished food production, resulting in skyrocketing food prices and increased competition for resources. In addition to the direct effects on food production, the eruption would have profound economic consequences. As supply chains break down and food prices rise, the global economy could spiral into a recession or even a depression. Industries that rely on agriculture, such as food processing, transportation, and retail, would be hit hard. Entire sectors of the economy could grind to a halt as the cost of basic goods becomes unaffordable. The economic fallout could also extend to energy markets, as disruptions to transportation and logistics systems lead to shortages of oil, gas, and electricity. Governments would likely need to implement emergency measures to stabilize their economies, but the long-term effects could last for years, if not decades. The social ramifications of such an event would be equally significant. In a world where the effects of climate change and environmental degradation are already being felt, a volcanic event of Yellowstone's magnitude could push societies to the breaking point. The sudden onset of food shortages, economic hardship, and social instability could trigger widespread civil unrest. Governments would need to enforce martial law in certain regions to maintain order and prevent chaos. Refugees fleeing areas devastated by the eruption and its aftermath could create international crises, as neighboring countries struggle to cope with the influx of displaced individuals. This could lead to a surge in global migration, as people from affected regions seek refuge elsewhere, further straining already overstretched resources in more stable areas. Meanwhile, nations with the resources to adapt or mitigate some of the effects of an eruption would face new challenges as they try to manage their own populations while providing aid to those in need. Countries with advanced infrastructure might be able to implement food rationing systems, provide shelter to refugees, and offer financial support to their citizens. However, even the most well-prepared countries would face significant challenges in the aftermath of a global volcanic event. The economic and political fallout could lead to a realignment of global power structures, as some nations struggle to maintain stability while others might rise to prominence in their efforts to provide aid and support to the affected populations. In the midst of this global crisis, governments and international organizations would likely work together to coordinate efforts aimed at reducing the impact of the eruption. This would involve everything from scientific research and technology development to humanitarian aid and disaster response. Countries would need to come together to share information and resources in an effort to tackle the multifaceted challenges posed by the eruption. At the same time, private companies and NGOs would likely play a critical role in providing the necessary infrastructure and support to those most affected by the disaster. The eruption of Yellowstone could also spark a significant shift in the way humanity approaches environmental preservation and disaster preparedness. As we continue to witness the effects of climate change and other environmental crises, the potential for large-scale natural disasters, such as supervolcano eruptions, becomes increasingly concerning. Governments may be forced to reevaluate their strategies for managing environmental risks and begin investing in more resilient infrastructure, disaster management systems, and sustainable agricultural practices. As we have seen with other natural disasters in the past, such as hurricanes, earthquakes, and wildfires, the response to these events often leads to lasting changes in policy and planning. The eruption of Yellowstone, if it were to occur, could serve as a wake-up call, prompting global leaders to take more proactive steps in preparing for and mitigating the impacts of large-scale natural disasters. One interesting development in this ongoing conversation is the growing emphasis on geoengineering as a potential solution to the threat posed by supervolcanoes and other catastrophic natural events. While geoengineering is still a relatively new field, scientists are beginning to explore ways in which we could artificially cool the planet in the event of a volcanic winter. Techniques such as solar radiation management and carbon capture could help mitigate the effects of the eruption on the global climate, providing some degree of relief to the most vulnerable regions. However, these technologies remain controversial, and many experts argue that we should focus on reducing the risks of such events in the first place rather than relying on artificial solutions. That said, the possibility of geoengineering may become increasingly important as we confront the threat posed by Yellowstone and other supervolcanoes in the future. While the idea of geoengineering is still speculative, the eruption of Yellowstone could also lead to an increased focus on space-based solutions. Some scientists have proposed that monitoring Earth from space, using satellites and other technologies, could provide early warnings of volcanic activity and allow us to respond more effectively. The ability to track shifts in magma chambers and monitor changes in atmospheric conditions from space could provide critical insights into the behavior of supervolcanoes, potentially giving us more time to prepare for an eruption. Although space-based monitoring is still in its infancy, the technology continues to improve, offering a glimpse into the potential for future solutions to some of the world's most pressing environmental challenges. As we continue to watch the developments at Yellowstone, it's clear that the potential for a major eruption could trigger a cascade of global consequences. The effects would be far-reaching, affecting not only the communities near the park but the entire planet. Scientists are working tirelessly to monitor and predict the behavior of the supervolcano, but as we've learned from history, even the most sophisticated technology cannot fully predict the unpredictable nature of these natural systems. The time may come when we must rely on our preparedness, our resilience, and our ability to work together as a global community to navigate the challenges posed by an event of this magnitude. Although the scientific community is working hard to monitor and assess any changes in volcanic activity, the general public's understanding of the situation can significantly impact both the effectiveness of disaster response efforts and the public's ability to adapt to any potential emergency. In times of uncertainty, misinformation and panic can be just as dangerous as the event itself, making it crucial to ensure that accurate, timely, and clear information is disseminated to those who need it most. In the age of social media, information, both true and false, can spread rapidly. The Yellowstone volcano, with its dramatic potential for global consequences, has already become a topic of intense speculation. News outlets, YouTube channels, and blogs are often quick to highlight theories, rumors, and sensational claims about what might happen next. While it's understandable that people are curious and anxious about an event of such magnitude, misinformation can cause undue panic, leading to chaotic situations that are difficult to manage. The task, then, is to ensure that the public has access to reliable, evidence-based information from trusted sources, such as government agencies and scientific institutions. One approach to managing public awareness is through the establishment of clear communication channels. These channels could include dedicated websites, social media platforms, and news broadcasts that provide real-time updates on Yellowstone's activity, as well as instructions on how to prepare for a potential eruption. Governments and agencies like the United States Geological Survey, USGS, and the Federal Emergency Management Agency, FEMA, already play critical roles in disaster preparedness and public safety, but during a crisis of this scale, coordination between these agencies and the general public will be essential to ensuring an effective response. Preparedness programs also need to be tailored to different audiences, especially given the diversity of needs and concerns across various communities. In areas near Yellowstone, for example, emergency evacuation plans should be well established, with regular drills to help people understand where to go and what to do in the event of a volcanic emergency. Beyond the immediate danger zone, individuals and families across the country and the world need to understand how to prepare for the long-term effects of a volcanic eruption. This includes having access to emergency supplies like food, water, and medications, as well as understanding the potential for disruptions to transportation, power, and communication networks. Ensuring that people are not only prepared for a sudden eruption but also for the weeks, months, or even years that could follow is vital to minimizing the fallout from such an event. One of the challenges in educating the public about Yellowstone's risks is that many people may not realize the severity of the situation. In the grand scheme of natural disasters, supervolcano eruptions are rare, and because we have not experienced an eruption of Yellowstone's magnitude in recorded history, the threat can seem distant or theoretical. This may lead to complacency or a lack of urgency in taking appropriate action. Public awareness campaigns could help bridge this gap by highlighting the real potential for disaster, without resorting to fear-mongering. It's important to strike a balance, showing the urgency of the situation without causing unnecessary panic. Moreover, these communication efforts must be accompanied by scientific education and community engagement. By fostering a greater understanding of volcanic science, the public will be better equipped to make informed decisions when it comes to preparing for an eruption. This could include educational programs in schools, community centers, and even on social media, where experts break down the facts about Yellowstone's activity, the risks involved, and the steps people can take to ensure their safety. When people feel informed, they are more likely to take proactive steps, such as stocking emergency supplies, creating family evacuation plans, and staying up to date on the latest news about the volcano's activity. Another important aspect of managing Yellowstone's potential eruption is the coordination between local, state, and national governments. Local officials, who are closest to the affected communities, must be prepared to provide timely, clear instructions to their citizens in the event of a crisis. These instructions might include evacuation orders, information about shelters and emergency services, and updates on the availability of food, water, and medical supplies. In coordination with state and federal agencies, local governments can ensure that the necessary resources are mobilized as quickly as possible to assist affected populations. At the federal level, agencies like FEMA and the Department of Homeland Security play a key role in disaster preparedness and response. Their involvement would be critical in coordinating logistics, providing financial assistance, and supporting the most vulnerable populations. In addition to their direct response efforts, these agencies also conduct research, promote preparedness programs, and partner with private sector organizations to build resilience against natural disasters. A major eruption at Yellowstone would be an unprecedented event, and FEMA's role would expand beyond their traditional scope, potentially involving international disaster relief efforts and the management of cross-border migration in the wake of a catastrophe. One of the most challenging aspects of coordinating disaster response to such an event would be the vast scale of the eruption's potential impact. As we have already seen, the eruption of Yellowstone could affect not just the United States, but the entire globe. In the aftermath of a large-scale eruption, relief efforts would need to be coordinated across countries and regions, with governments working together to provide aid and support to those most affected. This level of cooperation would require an unprecedented level of global coordination, which is why international bodies such as the United Nations and the World Health Organization could play pivotal roles in managing the aftermath. Given the likely long-term effects of such an eruption, ranging from global cooling to widespread infrastructure damage, it is essential that world governments begin planning for a future that includes such catastrophic scenarios. Investments in resilient infrastructure, renewable energy systems, and sustainable food production could help mitigate some of the impacts of a volcanic winter and ensure that societies can adapt and recover in the long run. Additionally, collaborative efforts to study supervolcanoes and monitor volcanic activity will continue to be essential in developing early warning systems and improving our ability to predict and respond to such events. Another critical area of focus is the role of scientific research in mitigating the risks posed by supervolcanoes like Yellowstone. While the eruption of a supervolcano may seem inevitable to some, much of the work being done by researchers today is focused on preventing, or at least reducing, the severity of such an event. The study of magma chambers, volcanic gases, and seismic activity is helping scientists to better understand the behavior of supervolcanoes and how they may change over time. By analyzing historical eruptions and comparing them to present-day data, scientists are identifying patterns that could offer clues about when and how Yellowstone might erupt. These insights, while not perfect, could provide the necessary information to evacuate populations and take preventive measures to minimize damage. As we come to the end of our deep dive into the Yellowstone supervolcano and the potential catastrophic consequences it could unleash, it's clear that the implications of such an eruption would be far-reaching. From global agricultural collapse to widespread economic instability, the eruption of Yellowstone would not just affect the communities near the park, but the entire world. Scientists are tirelessly working to monitor the area, but the unpredictable nature of supervolcanoes means we must remain vigilant and prepared for a potential disaster, even though such an event remains unlikely in the near future. The likelihood of Yellowstone erupting in the immediate future is still quite low, but that doesn't mean we should ignore the possibility. As we've seen, the changes in seismic activity, the shifting of magma beneath the surface, and the anomalies scientists have observed around the park all serve as reminders that even the most dormant volcanoes can one day awaken. It is this unpredictability that makes it so important for us to invest in monitoring, preparedness, and public awareness. Having systems in place to predict eruptions, educate the public, and coordinate disaster response efforts is vital for reducing the potential loss of life and minimizing the economic and environmental damage that would follow. As we look to the future, it's crucial to remember that Yellowstone and similar supervolcanoes are not just geological phenomena. They represent a reminder of the delicate balance our planet maintains. The Earth's natural systems are in constant flux, and while we may not be able to control them, we can certainly prepare for them. By investing in research, disaster preparedness, and global cooperation, we can ensure that if such an event were to occur, humanity would be better equipped to handle it. Our ability to adapt to challenges, whether they are natural or man-made, is what will ultimately determine how we face the future. The resilience of societies, however, is not only determined by how we respond to disasters but by how we come together in the face of them. Whether it's through scientific collaboration, emergency response coordination, or humanitarian aid, the world has shown time and again that in moments of crisis, we can rise to the occasion. As we continue to monitor Yellowstone, let's keep in mind the lessons learned from past disasters. Our ability to adapt, prepare, and cooperate will ultimately shape the outcome of our collective future. In the end, the question isn't just about whether Yellowstone will erupt, but how prepared we are for the unexpected. While we may never fully be able to predict the next great geological event, we can be certain that the world's best minds are working tirelessly to understand and mitigate the risks. For now, we watch, we learn, and we prepare, because the Earth, as we know, is an ever-changing force that waits for no one. If you found this exploration into Yellowstone's hidden dangers fascinating and want to stay updated on future topics, be sure to subscribe to our channel. Join us as we continue to uncover the mysteries of the natural world and the forces that shape our planet. Your curiosity is what fuels this journey. Don't miss out on what's next. Thanks for watching, and stay tuned for more deep dives into the wonders and warnings our world has to offer.